Oh, not again. Hey there. So, today I'm going to be talking about the Grainfather Conical Fermenter. I'm going to go through a brief product overview, and then I'm going to show how I designed and built a closed-loop water cooling system for the conical fermenter using the same cooling coil that I use for my counterflow chiller. Some minor modifications I did to the fermenter, and how I located the fermenter close to my other equipment. Pretty groovy, huh? Who the hell says groovy anymore? So, the Grainfather Conical Fermenter will hold 7 gallons of wort if you're a purist, and has a double-walled stainless steel casing with a layer of polyurethane in between the double walls to provide added insulation. The fermenter is shaped at the bottom with what they call the golden angle of 60 degrees, which, by the way, is made out of solid gold. No, not really. It refers to the angle which is good for settling yeast and trub if you're a purist, at the bottom of the fermenter. It has an integrated heating element and an integrated cooling sleeve for touchless thermal convection, to either warm or cool the wort while it's fermenting inside the conical fermenter. Now, the base model comes with a basic digital temperature display that you control manually by turning the power on and off to the fermenter. However, it's almost not worth mentioning because I don't think anybody actually uses the basic digital temperature display. The Pro Edition, which is the version that I have, comes with a digital temperature controller, and that attaches to the front of the conical fermenter via a magnet and a clip, and it makes electrical contact via a series of pogo pins in the back. The controller automatically operates the internal heating element, the optional cooling connection pump, or the optional glycol chiller. The newer Pro Edition GF30 conical fermenter, it comes with a wireless Pro controller, and that connects to the internet and the Grainfather app, so you can remotely control and monitor the temperature of the fermenter or multiple fermenters. If you have the older version digital controller, you can buy the wireless Pro controller and substitute it if you want the Wi-Fi connectivity. Now, the Pro Edition also comes with a dual valve tap, and that allows for yeast dumping and beer transferring using the same valve assembly. So, you say you're not satisfied and you say you want more. Well, tough. No, just kidding. Let's take a look at the optional accessories and cooling kits for the Grainfather Conical Fermenter. So, the Grainfather offers optional insulation coat or jacket accessories for the conical fermenter. I opted for the jacket because it's larger than the coat and it fits over the entire fermenter. Now, I know, a coat is usually larger than a jacket. Yeah, I don't get it either. The only modifications I did to the jacket was to cut off the Velcro flap covering the airlock hole because it just gets in the way. Also, I cut off the Velcro flap covering the digital controller because tearing the flap open sometimes will result in knocking the digital controller off onto the floor. Also, I wanted to be able to see the temperature status on the display screen during the fermentation to make sure that my cooling system is working properly. So, while we're on the subject of cooling, let's go through the 2 cooling option kits for the conical fermenter. Nice segue, eh? So you can either use the Grainfather Conical Fermenter in a temperature-controlled environment, such as a walk-in fridge or a cold basement, and just use the fermenter's internal heater. Or you can take advantage of the integrated cooling sleeve to cool the wort inside your fermenter. If you want to use the cooling sleeve feature, you'll need to connect cooling tubes to the fittings on the side of the fermenter, and then link up with either cold water or glycol as your cooling source. So here are the optional cooling connection kits available for the Grainfather Conical Fermenter. Now, the Grainfather sells 2 optional cooling kits. One is a basic cooling kit that comes with 2 quick disconnect couplers and 2 6.5-foot insulated hoses. This kit will allow you to connect the conical fermenter to the Grainfather glycol chiller. The other cooling kit is a cooling connection pump kit, and that comes with the same items as the basic cooling kit, plus a 12-volt DC submersible cooling pump and a 3-way wire harness. The 3-way harness connects to the power adapter, the submersible pump, and the digital temperature controller. The harness allows the controller to turn the submersible pump on and off based on the temperature setting on the controller, compared to the signal input from the internal temperature probe. As a side note, you'll save a few bucks if you buy the Grainfather Conical Fermenter together with the cooling connection pump kit as a package deal rather than purchase them separately. However, remember, there are two different cooling kits, and only the cooling connection pump kit comes with the three-way wire harness and the submersible pump. So now I'll show you how I use the cooling connection pump and my cooling coil as a closed loop system. Oh yeah. So the standard setup for the cooling connection pump kit is to put the submersible pump into a chili bin, such as a cooler full of ice water or ice packs, and then recirculate the cold water. I've also read about other ways to circulate the cool water using the submersible pump in a corny keg and then putting the keg inside a refrigerator, or using a NESLab refrigerator water bath. However, I took a different approach. I have a 50-foot 3/8-inch stainless steel cooling coil that I use to provide cold water to my counterflow chiller. So what if I could use the same coil to cool the water going to my conical fermenter? What if I could design a way to use the same cooling coil for both my counterflow chiller and my conical fermenter? That way I only need one cooling coil and only one cooler to do both jobs. Are you kidding me? In addition, wouldn't it be more efficient if the ice and the cold water were concentrated specifically to the immediate area surrounding the cooling coil so that the ice water would last up to 24 hours without adding more ice? Questions, questions, questions flooding into the mind of the concerned young person today. Frank Zappa. So here's what I did. So I built a two-stage double insulated cooler with two three-way valves to control the input and output of cold water, either to the counterflow chiller or the conical fermenter. The ice water around the coil cools the city tap water to the counterflow chiller when the three-way valves are set to the counterflow chiller position. The temperature of the water is monitored and controlled by adjusting the flow of the water through the cooling coil. The cold water flows through the counterflow chiller, cooling the boiling work down to around 80 degrees, and the hot water is outputted into my swimming pool, which doesn't warm the temperature of the pool one bit. When the valves are in the conical fermenter position, water is pushed through the cooling coil by the 12-volt pump. Then it goes through the fermenter and then back to the pump in a closed loop system. With this setup, I can put about 3 to 4 pounds of ice inside the cooling coil, put an ice pack on top of the coil, and the water will stay cold for around 24 hours until I repeat the process the next day. Now for me, the cooling tubes needed to go towards the back of the fermenter so they can be out of the way and connect to the plumbing coming from the cooler. So I needed to change the position of the cooling connections coming out of the conical fermenter from straight fittings to 90-degree elbows. Now remember, the Grainfather was designed in New Zealand, so the threads of the 90-degree elbows needed to be BSPP, British Standard Pipe Parallel, instead of NPT, which is National Pipe Thread, which is what we use in the United States. I found a 3/8-inch BSP male to 3/8-inch BSP female brass pipe fittings on Amazon, $12 for 5 pieces. I installed the male threads of the 90-degree elbows with Teflon tape into the fermenter and then installed the quick disconnect couplings from the Grainfather cooling connection kit into the female threads of the 90-degree elbows, again with Teflon tape. So next up, connecting the cooler plumbing to the fermenter. Yeah. So rather than use the red and blue colored tubing that comes with the cooling kit, I used clear tubing so that I could see if there was any air bubbles in the water. I specifically designed my cooler plumbing so that I could purge any air in the lines when I transitioned from the counterflow chiller position to the conical fermenter position. This will avoid the cooling pump cavitating due to an air bubble, which could possibly cause the pump to continuously run without pumping any water. So, I wanted to protect the fermenter from accidentally getting tipped over or bumped into, and at the same time locate it near my other equipment. The conical fermenter is a little top heavy, and it can easily tip over if, let's say, your 4-year-old grandson were to think it's a tackling dummy. So the first thing I did was cut out a section of my countertop so that I could recess the fermenter out of the way, plus locate it near my Grainfather boiler, my counterflow chiller, and the cooler. Now, before I get any cards or letters, this is not the countertop in my kitchen. Otherwise, there will be a chalk outline of my body on the kitchen floor next to the cutout. The next thing I did was to build a platform to raise the fermenter up and to provide better access to the dual valve tap. The conical fermenter has 4 plastic stilts that provide just enough clearance for the bottom of the dual valve tap. For me, 2 inches of clearance was not enough for me to work with, so I built the platform using PVC board with a cavity in the middle for better access. This makes it much easier to hook up the tubing for both the siphon tap and the yeast dump tap. Plus, the PVC board makes it easy to clean up if there's any spills or drips. Now the power cable connection's on the back of the fermenter, so I routed the cable harness with enough slack, otherwise known as service loop, to lean the empty conical fermenter forward and gain access to the threaded connector on the back. Then I cut the input and output tubing and installed the quick disconnect fittings. Okay, so locating the conical fermenter near my counterflow chiller was also important. I can connect the output hose from my counterflow chiller to my Blickman through meter and monitor the temperature of the wort going into the fermenter. By adjusting the flow of the wort to my counterflow chiller using the ball valve on my Grainfather boiler, I can control the temperature of the wort coming out of the counterflow chiller and into the conical fermenter. Also, the distance the wort drops down into the fermenter provides some added oxygen and foaming action, which will make my yeast nice and happy. So, using the Grainfather Conical Fermenter is easy. It's rather straightforward. I put the insulation jacket on the fermenter and insert it into its location. Then I lean the empty fermenter forward and connect the power cord to the back. I then connect the input and return water lines and install the digital temperature controller. I set the valves on the cooler to the counterflow chiller positions, fill the cooler with ice, turn the tap water on, and then pump the wort from the Grainfather boiler through the counterflow chiller and into the fermenter. While the wort is transferring to the fermenter, I monitor and adjust 2 temperatures. One is the temperature of the cold water going into the counterflow chiller, and the other is the temperature of the wort coming out of the counterflow chiller. By adjusting the flow of both the wort and the water, I can control their temperatures. When the transfer is complete and the wort is nice and frothy, I pitch the yeast, seal up the lid with the clamps, install the silicone stopper and the airlock. Next, I turn the lower 3-way valve on the cooler to the fermenter position and purge any oxygen bubbles in the line by running tap water through the fermenter and out through the purge line. After all the bubbles are gone, I shut the water off and close the purge valve. I then turn the upper 3-way valve to the fermenter position to create a closed loop system. Next, I turn the power switch controlling the digital controller to the on position and I set the desired temperature on the controller's display. I'll top off the ice, put an ice pack on top of the coil, and close the lid of the cooler. Done. Now, I know I went through the transfer process rather quickly, and there are a lot of other things that are going on during the process, such as taking samples for your hydrometer or refractometer to determine your original gravity, turning dials to control the temperatures, adding more ice, shouting out commands. Igor, throw the 3rd switch! Not the 3rd switch, master! But now that the wort and the yeast are making whoopee, let's talk about taking samples during the fermentation. I recommend using a sanitized wine thief or a siphon tube through the airlock hole to take samples for gravity readings. The reason being, if you use the dual valve siphon to fill up your test jar for your hydrometer, you run the risk of sucking star sand and any bugs floating around in your airlock into the fermenter. Plus, you run the risk of sucking in unwanted oxygen into your fermenter. While we're on the subject, if you're dumping yeast or taking samples using the dual valve assembly, I highly recommend using the Grainfather pressure transfer kit to make sure no oxygen is introduced through the airlock hole during the dumping process. Just replace the stopper in the airlock with the pressure transfer assembly without the racking pipe and apply 1 to 2 psi of CO2 while you're dumping the yeast through the dump valve. It also provides added pressure to help push the tube out of the dump valve rather than rely on the gravity feed. Well, that concludes my video on the Grainfather Conical Fermenter. If you have any questions or comments, let me know.